Hi, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at formal charge. So right up top we have two Lewis dot structures of silicon dioxide, which is also sand. It tells us that both of these structures are plausible, and in this ChemQuest we are going to determine how to decide which structure is better. So first, I am going to explain how both of these structures are possible. So right now, you should pause the video, read questions 1, 2, and 3. This information will help you when you answer those questions. So think about those questions as I'm talking. So pause it now. All right, so welcome back. Right here, we are looking at silicon dioxide. We start off with step one, counting the valence electrons. So that's why we have four, because there's four valence electrons in silicon. Six valence electrons in oxygen multiplied by 2 gives us 16. We then come down. We have our skeleton with 6 dots on the outside, on the outer atoms. Remember, those are the electrons. Next, step 4 is finding the leftover electrons. So we find the leftover electrons by taking the total and subtracting by the number of electrons that are on the structures. Remember, dots are 1, lines are 2. So we can add them up. Remember, I count the dots as pairs. 2, 4, 6, 8, 10, 12, 14, 16. So that's why there's 16. 16 minus 16 is 0. However, we are not done. We're not done because silicon, oh, whoops, let me focus. Oh, there it goes. So silicon does not have 8 electrons around it. Remember, every atom wants to have 8 electrons around it. This fulfills the octet rule. So what we have to do is create a multiple bond. Remember, lines are 2, so we can 2 electrons. Remember, dots are 1, so we can always remove 2 dots to create another line. So there are 2 possible ways. You can remove 2 dots there to create a double bond there. You could also remove 2 dots from the other oxygen to create a double bond on the other side. Oh, let me come back, refocus. There we go. The other possible way is to take 1 oxygen and remove 4 dots from it and then create a triple bond. So then if you look back at the information given to you, those are the 2 structures you see here, minus the squiggly lines. So that's how both of these fulfill all of the rules. They both have the total number of electrons, which is 16. That will help you answer 1 or 2. Now, when we think about 3, it tells us that in an experiment, scientists found that both of the bonds in sand were identical. So if you look at these 2 structures up here, structure A and structure B, which 2 bonds are identical? And that will help you answer that question. All right. So next we are coming on to, we're going to read about formal charge. So formal charge is a way to figure out the better structure without using an experiment. So we can start with a couple definitions. So the first definition you will need to know is formal electrons are electrons that aren't being shared. So write that down on the front. The next thing you should write down on the front is the definition for formal charge. The definition for formal charge that you will have to remember is the equation. You will have to know that it's the number of valence electrons minus the number of formal electrons. So next I'm going to talk about this picture a little bit right here. Talk about what I highlighted. So these arrows are pointing to the formal electrons, to this how to determine the formal electrons on oxygen, silicon, and then this oxygen to use in this formula down here. So you see that the highlighted in pink are oxygen's formal electrons. So always the formal electrons are always the electrons around the atom that aren't paired. Then remember, lines are 2 electrons. You can think about it as 1 electron there and 1 electron there. So then when we count our formal electrons, 1 electron goes to oxygen, 1 electron goes to silicon. Same thing when we look at this side. These pink electrons belong to oxygen atom number 2. They belong to them because they aren't paired. Unpaired electrons always belong to the atom that they're surrounded by. Next, we do the same thing. We have our bonds. Remember, you can think about it as one electron on each side of the line. The one side goes to silicon, the other side goes to oxygen. So then when we calculate this, we can see that this oxygen has 7 formal electrons. This silicon has 1, 2, 3, 4, has 4 formal electrons. And then we can see here that this oxygen has 1, 2, 3, 4, 5, has 5 formal electrons. So now when we calculate the formal charge, we plug it into our formula. So you see them do that right here. So they use the information right here with the formal electrons with the valence electrons from the periodic table. Remember, the column number tells us how many valence electrons they have. So silicon has 4 valence electrons and 4 formal electrons. So it's 4 minus 4. The oxygen atom number 1. Remember, this one is oxygen atom number 1. Remember, both oxygens have 6 valence electrons. So that's why you see 6 is the first number. And then oxygen atom number 1 has 7 formal electrons. So you see 6 minus 7, negative 1. Next, we can look at oxygen atom number 2. Oxygen atom number 2, again, it has 6 valence electrons because the group is in the periodic table. And then it's subtracted by 5 because it has 5 formal electrons, the electrons surrounding it, to get a positive 1. So next, question 4, we kind of already just did that. We verified the charges, the formal charges on the atoms in silicon dioxide. Question 5. So question 5 is very, very tough to answer, so I am just going to give you the answer. Question 5, the answer is the fewest. So the best structures always have the fewest numbers of formal charges. So what that means is the most formal charges of 0. So the structure that has the most formal charges of 0 is always the best. That will be helpful when you're thinking about some later structures. So I know this can be very confusing. So we are going to take a lot of time in class to practice calculating formal charges. I was also going to do out number 6 for you guys, so you guys can see me do out number 6, number 7. That will help you with number 8 and number 9 when you work on those. So again, I drew out the Lewis structure. I started off by drawing out the Lewis structure for CO3 with a -2 charge. Again, I used my highlighter to help us determine where the electrons go. So remember, the green ones go to the center. Remember, lines are 2. So you have a dot on one side, a dot on the other side, on all of your bonds. So this will help you when you are counting. Let me get this refocused. Yep, so now we can start calculating our formal charges. Remember the formula, I wrote it up top for us, is formal charges, number of valence minus the number of formal. So remember, oxygen has 6 valence electrons. So we can do 6 minus, and we got to count the formal electrons. Remember, the formal electrons are the electrons in pink, all of the electrons that are surrounding oxygen. Remember, the line, 1 goes to oxygen, 1 goes to carbon. So we have 1, 2, 3, 4, 5, 6, 7. So 6 minus 7, -1. We can do the same thing for this oxygen. So remember, it has 6 valence electrons. Now we can subtract it by the formal electrons, the electrons that are surrounding it. They're the ones in pink. 1, 2, 3, 4, 5, 6, 7. 6 minus 7, -1. We can do the same thing for this oxygen. Remember, it has 6 valence electrons. We got to subtract the formal, the electrons that are surrounding it. 1, 2, 3, 4, 5, 6. So in this case, 6 minus 6 is 0. Now lastly, we do it for the carbon. Remember, carbon has 4 valence electrons. Now we got to subtract it from the formal electrons, the electrons that are surrounding it. 1, 2, 3, 4. 4 minus 4 is 0. So now you've labeled and calculated all of the formal charges around your atom. Remember, just use the formula valence electrons minus formal electrons. Valence electrons are found on the periodic table. Formal electrons are found by counting the electrons that are surrounding an atom. Remember, when there's a bond, a line, 1 goes to the center atom, the other goes to the outer atom. Now question 7 is adding up all of the formal charges. So you can add up -1 plus -1 plus 0 plus 0. When you add that up, it comes out to -2. So 8 and 9, 10 and 11 are very similar. You're gonna draw a Lewis structure, calculate the formal charges, then add up the charge. So do the same thing that I did here for 8 and 9. When you get down to 12, remember, so when you get down to 12, what you need to do is compare the charge that you see in the ion to the charge that you add up in the formal charges. Do the same thing in 8. When you add up the formal charges in 9, compare it to the ionic charge in 8. Same thing in 11. When you add up the charges here, compare it to the formal charge in 10. What do you notice? And then lastly, question 13. So question 13, you're going to determine which structure is the better structure. Remember back to question 5. Question 5, we said that the structure that's the best has the most formal charges of 0. So what you have to do here is calculate the formal charge of every atom. Which atom has more atoms with a formal charge? Which structure has more atoms with a formal charge of 0? That one will be the best structure. Remember, if you have any questions, please circle them and write down your question. Remember to actually write down your question, so then when you come to class, you don't have to try to remember what you needed to ask me. Remember to put the vocab words on the front. It will help when you study for the quiz. As you guys know, vocab is a huge part of our exams. Hope everyone has a great day. I'll see you later. Bye.